For this lesson, we're going to introduce another strategy for solving quadratic equations, which is using the quadratic formula. If your equation is written exactly in this form, and you can identify A, B, and C, by plugging those numbers into this expression will give you the solutions, or potentially just one solution. So let's try this out in example 1, where I'd like to solve x squared equal to x plus 6. What numbers, if any, make this true? First thing to point out is that to apply this formula, my equation has to be written in exactly this form, and this one is not. I have to have 0 on one side, so I'll subtract x and 6 to the other side. And when I do that, I get x squared minus x minus 6 is equal to 0. So it's at this point where you can now identify what is A, what is B, and what is C. So it's not written in here, but really there's a 1 in front of that x squared, and there's this negative 1 that's in front of x, which means A is 1, B is negative 1, and C is negative 6. Those are the coefficients in front of the x squared term, the x term, and the constant at the very end. Going directly to my formula, x is equal to, I'm going to start plugging in my values. We have negative b, which is negative 1, plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a, which is 1, times c, which is negative 6, all divided by 2 times a, which is 1. So the next step would be to completely simplify this thing. And once we do, if there are 1 or maybe 2 solutions, they work for this equation up here. So let's simplify this. Okay, negative 1 is a positive 1, plus or minus. And this part could be completely done in a calculator where, okay, I have negative 1 squared, that's 1. I have a negative eventually times a negative, meaning I'm going to have a positive number, and 4 times 1 times 6 is 24, all divided by 2 times 1, which is simply 2. That means we have 1 plus or minus the square root of 25 all over 2. We can, of course, take this further. Continuing to simplify, we have x is equal to 1 plus or minus the square root of 25 is 5, all divided by 2. And this is where we have 2 solutions, which I'll break apart separately. We have x is equal to, it could be 1 plus 5 over 2. X could also be equal to 1 minus 5 over 2. The one on the left is 6 over 2, or simply 3. And the one on the right is negative 4 over 2, or just negative 2. So we did end up with 2 solutions, 2 real solutions, and they make this original equation true. This is, of course, not the only way to solve this equation. We could factor it, we could try completing the square to use our square root property, but this is yet just another way to go about solving an equation that has an x squared in it. Let's try this again in another example where I want to solve 2x squared minus 5x minus 3 is equal to 0. So this one is already set equal to 0, so I can simply identify a, b, and c. A is the value in front of x squared, which is 2. B is the value in front of x, which is negative 5. And c is the number at the end, which is negative 3. Okay, so going to my quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So the process in this one is going to be very similar to our last example where, okay, the negative and a negative is a positive. Underneath the square roots, I have 25 plus, because there's 2 negatives, 4 times 2 is 8 times 3 is 24. And this is all divided by 4. That came from 2 times 2. So the negative squared and the 5 squared became a positive 25. This negative and negative became a positive, which left us with 4 times 2 times 3, which is 24. So simplifying this, Get 5 plus or minus the square root of 49 all over 4. And this has a perfect square root. I have two solutions. X is equal to 5 plus 7 over 4, and x is also equal to 5 minus 7 over 4. The one on the left is 12/4, which means the value is 3. Here we have 5 minus 7, which is negative 2 over 4. This one actually stays as a fraction. It's negative 1/2. Those are the two solutions to this equation by using the quadratic formula.